Okay, we're going to finish up section 4 today talking about reference angles. Okay, so we're going to let theta be an angle in standard position. Remember, that means the initial ray is the positive x, the vertex is at the origin. Okay, its reference angle is the acute angle theta prime. Okay, this one up here. Okay, we call that theta prime. That's what that little mark right there is. Shows a prime. It's just not the same angle as theta. So theta prime is formed by the terminal side of theta and the x-axis. Okay? So if we think about that, if we want to kind of look at what's going on there, we put in our x and y axis here. And let's just draw in theta, and I'm going to put it over here. Okay? So there's our terminal side, there's some angle theta. So when we talk about theta prime, which is the reference angle, is formed by the terminal side, which is the red ray there, and the x-axis. Okay? So this angle right in here is theta prime. There is my reference angle. Okay? And the reason we use a reference angle is to take some larger angle and try to relate it back to an angle that would be in the first quadrant or make a right triangle. Because if you think about it, with our terminal ray here, remember we've been drawing in right triangles? Okay? So we can find the values based off of that reference angle, and they're going to be the same values for the actual angle of theta. Okay? So that's what we use those reference angles for. They're very important. They always go to the x-axis. That is so key. Key right there. The reference angle is always formed with the terminal side and the x-axis, never the y. Okay? So let's look at a couple examples. Theta is 300 degrees, and I want to know what its reference angle is. Well, so what I think about is I think, okay, where is 300 degrees? What quadrant does that fall in? Well, 300 is going to fall down here in the fourth quadrant. So what is the closest x-axis? Well, the closest x-axis would be at 360. So the reference angle is this difference between 360 and 300. So theta prime is 60 degrees. Okay? Kind of like when we talked about how you didn't really need to memorize the whole chart that we had. You just needed to know the first quadrant and then know which angles the others referred back to. Which family were they in? Well, that's the whole idea of a reference angle. I'm referring back to that first quadrant angle to get my numerical values, my absolute values really, and then deciding if it's positive or negative based on what quadrant the angle's really in. Okay? So number 2, theta is 2.3. Well, there's no degree symbol, so that must mean radians. So I have to think about how does 2.3 fall with respect to those quadrantal angles. My pi over 2, my pi. Well, I know pi is 3.14. What's pi over 2? Okay. Pi over 2 is like 1.57. So 2.3 is going to be somewhere in between. Okay. So my reference angle, theta prime, is down here in this range. So I'm going to take pi and I'm going to subtract my 2.3. Okay. And I get that theta prime is approximately 0.8416 radians. Okay? Because that's the difference between my 2.3, my theta, and the 3.14, which is the x-axis there on the negative side. Okay? All right, number 3. Negative 135 degrees. So I have to think about what quadrant does that end up in. Okay, I'm going negatives now. So negative 90, negative 180. Okay, well, negative 135 is going to be somewhere in between. Okay, so There's my negative 135. So my reference angle is going to be over here somewhere. What is the difference between negative 135 and negative 180? Well, how far is it from negative 135 to negative 180? And if you go ahead and figure out the difference in those, you'll find that theta prime is 45 degrees. So everything I need to know about negative 135 degrees, I can find from 45 degrees, and then just remember what quadrant I'm in. And in the sine, since I'm in the third quadrant, I know that all of my sines and cosine values would have to be negatives. Okay? And let's check at number 4, negative 13/6 pi. Well, again, I'm going negative, so I'm going to go this direction. Well, 13 divided by 6. Is that more than 2? Is it less than 2? Where does that fall? Well, 13 divided by 6 is a little bit more than 2. Okay, 13/6 would be 2 1/6. So that angle is going to start. It's going to go all the way around and come back to the fourth quadrant. So my reference angle again is between the x-axis. My reference angle is between negative 2 pi and negative 13 pi over 6. So theta prime ends up being pi over 6. We want our reference angles to always be positive values so that we can relate them back to those first quadrant angles. Okay? So the reference angle for negative 13/6 pi is actually pi over 6. Everything I want to know about negative 13/6 pi, I'm going to get from the pi over 6, and then I'm just going to use the quadrant I'm in to make sure I get the appropriate signs. Okay. So, finding the trig function of any value, no matter what it is, the first thing we do is we figure out what is the reference angle, theta prime. Okay? Remember that theta prime, that's our reference angle. Okay? So we figure out everything from the reference angle, and then we just use the appropriate sign dependent on the quadrant. Okay? So if I'm talking about cosine and I know I'm in the third quadrant, I know the value has to get a negative. If I'm talking about sine and I know I'm in the second quadrant, then I know it's going to be a positive. Okay? So it's using the values of the reference angle and then just changing the sign to fit the quadrant that my angle actually sits in. Okay. So let's look at some examples with some of the angles that we kind of should be familiar with already. But let's look at number 5, cosine of 4 pi over 3. So all I'm thinking about is what quadrant does 4 pi over 3 fall in? Well, it's a little bit more than 1. Okay? So the angle is going to be down here somewhere. So my reference angle, and here theta prime, is going to be the difference. So I'm going to take 4 pi over 3 and subtract pi. I'm going back up this way. Okay? And 4/3 minus 1 is 1/3 pi. So then I think about, okay, then all I really need to know is what is the cosine of pi over 3. And that's one of our special angles. That's one we're supposed to know at this point. And the cosine of pi over 3 is 1/2. Okay? So the cosine of 4 pi over 3, since I'm in the third quadrant, I know the cosine has to be negative. So I know that this value is going to be a 1/2, but since 4/3 pi is in the third quadrant, it becomes negative 1/2. Okay? So I use the reference angle, I find out the information about the reference angle, and then I go back to my original angle and decide if it's positive or negative based on the quadrant. Okay? Number 6, tangent of negative 210. Well, negative 210, that's a little past 180, so that's going to be over here somewhere. Okay, there's negative 210. So I need the reference angle. The reference angle is going to be the angle in between the terminal side and the x-axis. Well, the x-axis was negative 180. This was negative 210. So what is the positive difference between those? How far are they away? Okay, well, theta prime is 30 degrees. So I gotta say, okay, what is the tangent of 30 degrees? Well, I don't have the tangent memorized. What I remember is that the tangent is the y over the x, or the sine over the cosine. And I know the sine of 30 is 1/2. The cosine is square root of 3 over 2. Those 2's will end up dividing each other out, and I'm going to end up with square root of 3 divided by 3. Okay? So I know the numbers are square root of 3 divided by 3, but then I have to go back and look. My angle that I'm working with, theta, is actually in the second quadrant, and in the second quadrant, the tangent is negative because it's y over x. So the tangent of negative 210 degrees is negative square root of 3 divided by 3. No calculator, that's an exact value. Okay. All right, number 7. Cosecant 11/4 pi. Well, again, the first thing I got to do is I got to figure out what quadrant it is. 11/4. Well, 8/4 would be 2. Right? So 4 into 11, I know that 11/4, that's 2 and 3/4. Okay? So if I were going 2 pi, 2 pi would take me all the way back to here. Okay? 3/4 is going to be more than half, but less than another 1, so I'm going to be right in there. Okay? So my reference angle, here's my reference angle down here, theta prime. Okay? Well, I've already gone one full circle. I've already gone 2 pi, and I'm coming back around. So now this value is actually 3 pi. So I'm looking at theta prime is going to be 3 pi minus 11 pi over 4. Remember, I always want my reference angle to be positive. So 3 would be 12/4 minus 11/4 gives me pi over 4. Okay? And cosecant. So what am I doing? I'm really thinking about now, okay, I need to know the cosecant of pi over 4. Well, I don't remember what cosecant is, but what I do remember is that the cosecant is the reciprocal of the sine. And I know that the sine of pi over 4 is square root of 2 over 2. Okay? And sine relates to y. We go back to our angle, okay? Our angle is in quadrant number 2 where y is positive, so I know it's going to stay square root of 2 over 2. So now I need to take the reciprocal. I need to flip it over. And then I need to simplify. That's going to give me 2 square root of 2 over 2, which means I have square root of 2. Okay. All right, number 8, last one here. Sine of negative 17/6. Well, 17/6. I need to know where that falls in the grand scheme of things. Well, 6 will go into 17 2 times. 5 left over. Okay? So I need to figure out now which quadrant am I going to be in. Well, I know it's negative 2, so I know that I've gone all the way around, and I'm going another 5/6, which means I'm almost going another whole 1. Okay? So since we're going negative, this was negative 2 pi, and this is going to be negative 3 pi. So now I need to know what is the difference, how far between, okay, I'm going to be in here somewhere. So my reference angle again is going to be between negative 17/6 and negative 3. So negative 17/6 minus negative 3. Okay. Well, 3 would be 18/6, so this is actually going to become plus 18/6, and I'm going to get pi over 6. So I just need to know what is the sine of pi over 6. Sine of pi over 6 is 1/2. But where is theta? Theta is actually in the third quadrant. In the third quadrant, the sign is negative. So the sign of negative 17/6 pi is going to be negative 1/2. The sign is negative in the third quadrant. So even though my reference angle's value was positive, I got to think about what quadrant my actual angle is in and then assign the appropriate value. Okay. All right, a little different type of problem. Theta's in quadrant 2. Okay, that makes it easy. At least we know where it's at. Okay, so we're over here somewhere. Sine of theta is 1/3. Find the cosine. Okay, well, there's a couple of ways we could do that. We could draw the triangles. Okay, we could remember that the sine is y divided by r. Cosine is x divided by r. So I'm going to use y and r to find x. And if you go back, x squared plus y squared equals r squared. Remember that from the other day, from the previous lesson. So I have x squared plus y squared, which is 1, equals r squared. Okay. So x squared is going to be 9 minus 1, which is 8. And when I take the square root, that's going to be 2 square root of 2. So cosine of theta is x divided by r. Done deal. Okay. Now, we're in the second quadrant. So in the second quadrant, the cosine, which is related to x, cosine has to be negative. So our final answer is that the cosine of theta is negative 2 times the square root of 2 divided by 3. Okay. So we figured out our value, got our number, and then went back and said, okay, what quadrant are we in? We're in the second quadrant. Well, in the second quadrant, cosines are negative because they're related to the x's. Okay? So, take a minute, pause the video, and try number 10 and see if you can get that before you watch the solution. All right, quadrant 4. Theta's in quadrant 4. We're down here. We've got the sine, we want the cosine. So again, we're going to use x squared plus y squared equals r squared. I have the sine. The sine is y over r, which means y is 3. Y is 3 and the r is 5. We know the cosine is x over r. So when we solve this here, we're going to have x squared equals 25 minus 9, which is 16, and x is 4. Okay. So cosine is x over r. So cosine of theta is x, which is 4, divided by r, which is 5. I go back and I look at my quadrant. I'm in the fourth quadrant. In the fourth quadrant, x's are positive, so my cosine stays positive, and that's it. I'm done. So tomorrow in class we'll work some more problems and do some more with finding these reference angles, finding the trig values of any angle by finding out the information of its reference angle and using the sign to match the quadrant that we're in. Okay? See you tomorrow. Thank you.